Hi, I'm Kyle Bradbury. In this video, we'll be walking through a demo of how to use Git for version control using command line tools. This follows up a video on how Git works and how to incorporate it into your workflow, and I'll leave a link to that in the description below. So let's get started with the demo. So you've started a new project and you want to start by initializing your Git repository. Pretty simple. You go to your directory that you want to be in. In this case, I'm in this demo directory here. You can see it mimicked here throughout this video. And you type the git init command. Done. Initialized empty Git repository and are essentially ready to go. You can always use the git status command to check the status of your Git repository. So if we look at git status, so we're on branch master, no commits yet, so no versions to be saved here, and master is the standard branch. Nothing is to be committed. There's nothing in the directories. Okay, so we've gone ahead and added a couple of files into our directory. myfile.txt, which has some text and could have code, whatever you were doing here, and another file which we actually don't want to commit to our repository. So let's look at how we actually stage these files for being added to the repository. So we check our git status command and we see while there are no commits, there are a couple of files that are not tracked. So we can go ahead and add all of the files in our current directory by using the git add and then the period after that to add every file that's in there. So if we go to git status, we see that changes to be committed. These have both been added to the staging area. Now, we earlier said though that we didn't want to add another file.txt. So I can go ahead and remove that by using the git reset a command and use another file.txt. And then if I git status, so that will take it out from the staging area, and go to git status, and we see that my file.txt is ready to be committed, but the other file is not tracked. We've removed it from the staging area. So this is certainly very helpful. Now, of course, we can always git add a single file if we wanted to add it back in, and we could remove all of the files from the staging area if we so wished, and we can easily move the files in and out of there. Now, let's say we actually wanted to do myfile.txt and add that in and along with another file.txt. We could git add both of those this way as well. Just want to show you all the possible combinations of how to go about doing this. And so the one you'll probably use the most frequently is git add all. So now we're all set. We have our files in our staging area, and now we're ready to commit those files to the version history. So to commit these files, we use the git commit command, and I highly recommend always using the -m and then message version of this. So what you would do is say git commit -m, and then what's the message that you want to use that basically says what version is this? What was the change that was made? This is going to be our initial commit. So if you go ahead and run this, what this will do is it'll say, okay, on our master branch, we have our initial commit has been made from our text that we provided. 2 files were changed. In this case, they were added, and there were 13 insertions, 1 for each of the lines in each of those files. And so if we now use git status, we see on branch master, nothing to commit, working tree is clean. Great. So now let's say we go ahead here and decide we want to make some changes to my file. So maybe this is the text I never wrote. and no comments but my own. Okay, save that. Now if we do git status, what that's going to tell us is that there have been some changes made. So we see myfile.txt has been modified. So let's look at how we can see some of the differences between these files. So to look at our version history, we can use the git log command. And this shows us we have two commits, two versions that we've made, the initial commit and the one where we modified our little pseudo poem. And so we can actually use the, this is pretty verbose with these long hashes here. We can use the git log one line command, and this shows a much more condensed version of it. So here are our hashes of these different versions in one, and modified poem initial commit. So this is much more concise to explore here. So now what I want to do is explore, what if I want to hit the undo button? And so I want to undo this last change. Maybe I didn't want to make those changes to that poem. So what I can do is, copy this last, the hash for the corresponding that change, and use the git revert option along with that hash to basically undo that change. Now, this is, you do this if you want to get rid of changes that have been already committed to the repository. If you're just staging them, you can use the git reset command to take to undo changes that were staged for being committed. And so here, if we use git revert, what this is going to do is going to bring up the Vim text editor, which allows me to create a message that's associated with this new commit, this undo commit. And so, this is fine here. It has revert modified poem. Of course, to get out of this, if you're not familiar with Vim, you hit the escape button and then colon, as you can see what I'm typing here, colon W, meaning save this text that's been added as my my statement that I'm going to use associated with this commit, and then Q to quit Vim, and then hit enter. And so now there's been a new commit where the commit is reverting and undoing the changes from the modifications to the poem. So if I do git log one line, I see that there's a new commit, a new version, reverting modified poem. And if I go back to my file, I see the original text before the change. And so it has effectively been undone using the git revert command. So let's say I make some changes to my current working directory and want to see how that compares against the latest commit. So I'm going to commit two quick changes, and then we're going to look at how to compare some of those. So, I have another file here. Don't commit this file. So let's say I actually did want to commit that file. So I'm going to go ahead here and make a change and say this is change 1. Now I'll create a second change that I'm going to put change 2. And I'm going to add that to the Git repo as well. Okay, I've made two quick changes here, and now let's say I open up the file and I've added one final change. So now if I save this, I can put this file over here. Now if I use the git diff command, what this is going to do is it's going to compare the changes that I see here to the latest commit. So the latest commit had been changed too. So if I look at git diff, it just shows me it added final change. But if I did git log, I can compare any of these changes here. So let's say I wanted to do git diff, not between my current change, but let's say I want to look at between the second change and the first change. I can copy the hash that corresponds to that, the ID that corresponds to that commit, and the first change. And if I look at that, between the first change and the second change, we added change 2. So it's showing us the change that has been made from one version to the other. So this can be very useful for seeing what's been changed, for seeing what you've changed since the latest commit, and for making decisions around whether or not you want to commit that file. And of course, one of the main features of Git is being able to create different branches so that you can have, you know, your main workflow on one and develop other features and other branches without, you know, necessarily corrupting the original branch. So how do we go about doing this? Well, first of all, let's look at what branches are available to us now. We can use the git branch command to check that. And there is one. It is master, and we can see by the star that we're on branch master. Well, we can create a new branch. Let's say we want to create a development branch. We're going to call it dev, like so. And if we then run git branch, we can see that we have now a master branch and a development branch. So, you know, we can easily switch to the development branch by using the git checkout command and telling it which branch to check out. So we're going to check out dev. And so it tells us that we've switched to branch dev. And so this literally changes all the files in our current directory to be reflected, to reflect the latest commit, the latest version in that particular branch. So let's show how this works. Right now, the two branches are the same, but let's say I change some stuff in branch dev and say, you know, this is my development branch, to be very, very clear about what's going on there. So I can look at git status, and you can see we're now on branch dev here, but my file.txt has been modified. So I'm going to go ahead and add it and git commit -m, you know, changed development branch. So git status, we're all up to speed here. Now, what I'm going to do is actually, you know, we have my file here, looking at it again. This is my development branch. I'm going to check out the master branch. Git checkout. So this is going to switch to the master branch. Okay, switch to branch master. Now if I open up that same file in that same directory, it does not have the stuff that was added in the development branch. It's a completely separate thing. By using git checkout, it actually changes the files in my local file structure to match the latest branch that's there. So I can go ahead and happily make changes along this development branch without impacting my master branch at all. Now let's say I've been doing some work on my development branch, and so let me switch back to that now. So I'm back on my development branch, and you know, I want to incorporate this line into my master branch. So what I can do is say, okay, well, let me switch back to the master branch and merge in that change into the master branch. So I can do git merge. So first of all, in master, remember my file, that there's nothing about the development branch here. So I can go here, git merge, and I merge from the directory that I want to merge into. So I'm on branch master, and I want to merge in, you know, branch dev. So I run that. Beautiful. It's added that in. Now if I look at my file.txt, it has that updated. So I've merged that in, and I can even go so far as to then remove the branch with that change. So I could do git branch delete dev, And if I look at git branch again, now I'm just back to my master branch. So that's an example of a nice clean merge. Not all the time does the merging process go so smoothly. So sometimes there are conflicting changes that occur, and so we have to do things a little bit differently when that's the case. So let's look at, first of all, what branch are we on? We're on master. So let's look at the file in master. And you can see we have this no more comments on master. And that was a change that I added from the just no more comments one on the last piece. So this on master was added. And then let's go git checkout dev. And when we look at that file, this was a change here. No more comments on development. This is my development branch. So actually, this no more comments line has been changed in both locations, but to different things. And so what we're going to see is this can be a little bit more challenging when it comes to trying to do a git merge. So if we switch back to master, let's say we want to merge it into master, and we want to do a git merge from dev. Auto merging my file.txt conflict, and there was a merge conflict in my file. So it tells us automatic merge failed, fix conflicts, and then commit the result. So if we do git status, you have unmerged paths, my file.txt has been modified. So if we look here, it hasn't committed anything because it wasn't able to just automatically merge that together. So if we open this up, oh, there's some weird stuff going on here. This is basically saying, here's the version from head, here's the version from the development branch, and we have to pick which one you want. So what you can do here is, okay, we're going to delete this, and let's say we actually wanted it to be on master, right? So we can make our edits, and now we've directly edited this file, save it, and then we can git add, and then git commit, and merged development into master. And now that's been changed, and when we look in this file, we're good to go with those merged changes. So oftentimes, you don't just want to work on a local repository. Everything we've done so far has been on our local repository. It's been our own local computer. But often to collaborate, you want to work in a remote repository. It might be something like GitHub or GitLab, or it might be something else that might be internal to your organization. But let's see how we go about getting our local repository up on a remote server. So you can go to your GitHub page, create an account, sign up, and then you can go to create a new repository. So I'm going to create a repository called demo repo. You can add a description, all that sort of stuff, but we don't really need that. We just create a repository with that, and that allows us to create, to have this, this particular address that we can use to connect our repo to. So go ahead and copy that, whatever, not obviously this specific one, but whatever one you've created. And you can go here, back to your command line, and start by setting up git remote. And you do this by creating a name for whatever your remote will be called. And so that's a typical choice to say, okay, the origin of this repository is a certain address, and we can paste in our address there, hit enter, and voila, we've set that up, and we can check it. So git remote -v will give us a sense of which ones are which, and you can see here that for fetching, which means getting the latest update from the remote server, and pushing, we're to push the content that we're sending from our repository when we use that command. They've both been set to the address that we set here, and we have the name for it is origin. So great, we can go ahead now and git push, and what we use here is Where are we pushing to? We're pushing to origin. And what branch do we want to push? Well, we want to push branch master in this case. Okay, we hit that command. Now you have to enter a password. You'll have to have set that up for GitHub, so it allows you to do that. So I'll enter in my password now. And saying, okay, found some objects, compressing them, sending them, done. So now if I go back over here and refresh the screen, voila, I have my files there. And if I look at the contents of it, I see that I've pushed it directly up to there. Now, another option that you have for starting a Git repo, let's say you want to start by working off of somebody's existing repository and build on it. So you can use the clone command to do this. So let's say I was interested in this particular repository here. So what I can do is go over here to this clone or download button, and it gives me clone with SSH option. I can copy this, and then I can simply go to my command line and run git clone and paste in the address. And I'm in a new directory here called clone demo. And so I run this clone into Python. It wants my passcode. Happy to provide it. I run that, and it downloads, and voila, I have all of the information there that's been cloned. And this is now a Git repo. And so if I go into cd python and I run git status on branch master, your branch is up to date with origin master. And so I can start working on it starting from that point right there. When you start working on the project after you've stepped away from it a while, you may want to use the git pull command. Git pull essentially accomplishes two things. One, it fetches the latest commit that's been made to the remote repository. So if you're working with a team and they've been committing lots of changes to the remote repo, before you start working on it, pull those files down, and that will update your local repo to match the remote repo. That way you're ready to go and add changes from wherever the project is currently left off. And git pull essentially does two things. One, it does a fetch, and then number two, it performs a merge. So the fetch just grabs the files from the server and basically updates your local directory, and then merges it in and commits it to your local repository. So the combination of those two is very useful. So a good workflow is I start my day, I pull down whatever's been committed to the repository since I last worked on it, and then I work from there off of a nice clean version. So I hope this tutorial was helpful in getting you started with some of the basic Git commands in practice, and thanks for watching.